All right, let's say that if we have an arithmetic sequence. So remember, an arithmetic sequence is a sequence where to get from one term to the next term, you're going to have to add or subtract by, in this case, something known as the common difference, a common difference. So notice how every time we go to the next term, we have to add by 1. Let's say that this sequence goes on until 100. So it's 1, 2, 3, 4, 5, 6, 7, 8, and all the way up to 100. I want you to find out the sum of all of these terms. So if I were to add all of these terms up, what would I get? And luckily, there's a formula for us to do this. It tells us that the sum up to the nth term, so the sum of every number, including, the nth term, this is going to be equal to the average of the first and the last term, right? So the average of the first and last term is just going to be a sub 1 plus a sub n divided by 2, and it's going to be multiplied by the number of terms there are. Or another way that you might be seeing this expressed is you can say that the sum up to the nth term is equal to the amount of terms divided by 2 times the first and the last term. Now, I usually prefer this formula right over here because this is way easier to remember, right? The sum up to the nth term, including this nth term, right? This is going to be equal to the average of the first and the last term times the number of terms there are. This is just way easier to memorize than this other one. So I usually stick to this. So let's do this problem. In this case, we want to find the sum up to the 100th term. So it's going to be equal to the first term, which we know is 1, plus the nth term. In this case, a sub n. This is the same thing as a sub 100, right? If we're trying to find the 100th term, right? If we're trying to find the 100th term, well, we're going to have to know what a sub 100 is, right? Notice how the n's match up here. And then if I want to find out the sum up to the 100th term, well, I have to find out what a sub 100 is, right? So a sub 100, we know that's just 100, right? We kind of drew that out for you guys. So it's going to be 1 plus 100 divided by 2. And then you're going to multiply that by the amount of terms there are, which in this case there's. If you put this into your calculator, you'll get 5,050. Now, I'm not going to go over a proof of this formula, but let me just conceptualize this formula for y'all a little bit. So imagine if we took the first and last term. So we took the first and last term and we added them together, right? So we're essentially creating a pair of numbers, right? So 1 plus 100 is 101. Imagine if I took this 2 and I added it to 99. Notice how I also get 101. I can do the same for 3 and 98, right? I can add these up, and I also get 101. So notice how if I keep doing this, I know that I have 100 terms. So if I pair these numbers up together, I would get 50 pairs, right? I would get 50 pairs, right? And we know that each pair has a value of 101. So 50 times 101, well, that gives us the same answer as before, 5,050. And this is actually where this formula comes from. This n divided by 2 times a sub 1 plus a sub n. These two things are the same thing, but you can kind of see how this formula right over here fits what we did right over here. Right, what we did was we took the sum of the first and the last term, which we did, right? 1 plus 100 is 101, and we multiplied it by the amount of terms divided by 2, because we're creating pairs of numbers, right? So there's going to be half them. If we have 100 numbers, we're going to be able to create 50 pairs. So it's going to be half the amount of the total terms there are. So let me just write this. So this n divided by 2 represents the pairs that we create with this sequence. So in this case, we created 100 divided by 2, which is 50 pairs, multiplied by first and last term, which is 101, and we get the same answer. Let's say if I had this sequence right over here. I'm trying to find the sum up to the 40th term. How can I do this? Feel free to pause the video. Well, in this case, I could just use this formula, right? So in this case, f sub 40 is going to be equal to, in this case, the first term, which we know, plus a sub n. So in this case, we want to find a sub 40, right? Divided by 2. And then this is going to be multiplied by the amount of terms we have. So in this case, we have 40 terms, right? So it's going to be multiplied by the amount of terms we have. Now, how do we find a sub 40, right? We want to take the average between the first and the last term. So if there's 40 terms in if there's 40 terms we have to find, the last term is going to be the 40th term, right? Well, how do I find this last term? Well, you might recall that if you want to find out the nth term of a sequence, of an arithmetic sequence, you would just use this formula. So it's going to be, if you want to find out a specific term in a sequence, so you're in this formula right over here, you're trying to find out the sum up to a certain number of a sequence. You're trying to find a sum. But for this formula, you're just trying to find out one specific term of that sequence. And it's a sub n is equal to the first term plus the amount of terms minus 1 times the common difference. So in this case, if I'm trying to find out a sub 40, this is going to be equal to the first term plus n minus 1. So it's going to be 40 minus 1, right? Notice how if I plug in 40 here for n, I also have to plug in 40 here for n. So, just keep that in mind, right? So 40 minus 1 times the common difference. The common difference just represents the amount of, just number you have to add to get from one term to the next. So the number I have to add to get from 1 to 6 is 5, right? That's going to be my common difference. Doing the math, we get 196. So a sub 40 is equal to 196. And using that information, I can plug it into this formula. So it's going to be 1 plus 196 divided by 2, and then it's going to be times 40. So this is going to be equal to 3,940. And that is going to be our answer. A stadium has 30 rows of seats. The first row has 20 seats, the second has 24, third has 28. This pattern continues with each row having 4 more seats than the previous one. How many total seats are there in the stadium? So in this case, we want to find out the sum of all of the seats in my stadium. All right. Now, how do we do this? Well, all right. So we know that the first row has 20 seats. Second row has 24. Third row has 28. And this goes all the way on until my 30th row, right? So in this case, what we want to do is we want to find out the sum up to the 30th term, because there's 30 rows of seats, right? Therefore, there's going to be 30 terms, right? So the sum up to the 30th term is going to be our first term plus our, in this case, 30th term divided by 2. So it's the average of the first and the last term times the number of terms there are. Well, there's 30, right? Now, if I wanted to find out what a sub 30 is equal to, well then, if I wanted to find out what a sub 30 is equal to, I would just use this formula to find out a specific term in a sequence. So a sub 30 is equal to the first term, which we know is 20, plus the term, so 30 minus 1, right, times the common difference. So in this case, our common difference, well, notice how we're adding 4 every time. They even tell us in the problem, 4 more seats than the previous one, right? So our common difference is 4. So 29 times 4, that's 116, plus 20 is 136. So now we know a sub 30 is 136. Let's just substitute that in there. So 20 plus 136 gives me 156, divided by 2 gives me 78, times 30 is going to be 2,340 seats in total. That is a pretty big stadium, if I would say so myself.